Starting back up with part 2 of module 1 of math from the 4th paper test from the College Board site. Again, these are going to have blue book problems in them. So yeah, we made it to number 14 last time. Let's start with number 15 here. So I see we have a slope and it passes through the point 910. Which equation defines line T? Yeah, so the first thing that comes to mind is, well, it's nice there to give us the slope, and then we just need to figure out our y-intercept, right? So if I would just plug this into my y equals mx plus b, so my new equation would be y equals negative 1/3 x plus b. And then you notice how there is still our missing y-intercept, but there is also an x and a y. And a point they give us is also an x and a y, right? So I just plug that 9 and 10 in. So I should get 10 is equal to negative 1/3 times 9, which is nice, plus b. And I'm going to go ahead and simplify that little part there. So it's going to be 10 is equal to 9 divided by 3, so negative 3 plus b. Or add my 3 over, and 13 is going to be equal to my b. So now we have the two most important things about our line. We have our slope, and we have our y-intercept. So I look through my answer choices for both. That's a 13 slope, a 9 slope, and then we have two negative 1/3 slopes, but this one has the plus 13. So it's going to be D here. Not too bad. Yeah, that's how we get our y-intercept. We just plug our point in, and we're going to shift down to number 16 here. And it looks like, okay, we got a nice word problem. Let's get a different color here. So we have the function, we have an exponential function. So remember, this is going to be our initial or our y-intercept. This is going to be by how much we're changing, and it looks like it's going to be about 3.4%. And it's an increase, right? So we want to master these equations. The way I got 0.034, or rather 3.4%, is if we start at 1, ask yourself, well, how much have I increased from 1? And that's going to be 0.034. And to get it into percentage form, we multiply by 100, right? And that's just going to get us 3.4%. So again, if I'm looking in the context of the problem, maybe they'll say something like 3.4% increase or starting at 206. So models in dollars, a bank account by the end of the year. So it looks like we're going to be increasing very slightly. So if this is a bank account, I deposited 206 and it's increasing by 3.4% each year. Which of the following is the best interpretation of f of 5? Okay, so before I even look at what it's equal to, always ask yourself with these f ofs, what did we just replace? We replaced an x with 5. What were the units of x? Number of years. So f of 5 is saying, and I'll just type it out, in 5 years, right, that's how I'll start it, is approximately equal to 243. Our bank account, our bank will equal $243, right? So if we started at 206, it looks like we'll be gaining, what is that, like 37 over the course of the next 5 years. So again, these problems are all going to be about mastering the equation before I even look at the problem, because look how easily we just went through that, right? Let's look for the answer choice that kind of matches what we described. The value of the bank account is estimated to be approximately $5. No. The 5 is supposed to represent years. The value of the bank account is estimated to be approximately $243 in 1962. Let's see what year we started at. 1957. So that's 5 years after 1957. That's the right units for x, and we should equal 243 after that period of time. These are great problems. You know, with enough practice, we're looking forward to these exponential function problems because they can't get too crazy with these. Jumping up to another one here, I see number 17, and let's shift this over. This one looks like a good one. We got a rectangular region, the ratio of its length to its width is 35:10. Okay, so I'm always going to draw these. Maybe let's clear up a little bit of this because I don't want it to get it confused. Okay, so I'm going to draw my rectangle over to the side here, right here. And again, the ratio of its length to its width. So I'll just say, okay, this guy's going to be the length, and this one's going to be the width. So remember, it doesn't have to be 35 and 10 for the length and width of my rectangle. It could be 70, 20, 105, 30. It's just at least this, right? It's at least 35 over 10, and it can go bigger. If the width of the rectangular region increases by 7, okay, so this is going to be your classic draw two shapes. The width increases by 7, so that's going to be 17. How must the length change to maintain its ratio? Okay. So this is the perfect problem to set up a proportion, right? Proportions are going to help us a lot on a lot of different problems. It's very versatile. But the main criteria for proportion is you know 3 terms and you don't know a 4th term, right? A proportion is going to look something like this. We're going to have, the rectangle's kind of in the way. Maybe I'll try to squeeze it up here. So our proportion is going to be a fraction is equal to a fraction, and we want to maintain this kind of change that's occurring, right? So it looks like our first fraction, and as long as you stay organized, it doesn't matter what number I put. Maybe I say 35 over 10, and then I know that my width has changed to 17, and then I don't know what this new length is, right? So this is the perfect circumstances for a proportion. Remember to try to look for using this in the future too, because it's a really good tool to have. And again, once we have it set up, all we have to do is cross multiply. So let's go ahead and see what number we get here. 35 times 17, and then we'll divide by 10, but I'll show it. 35 times 17, so we should get 595 is equal to 10x, and then divide by 10, and we get our new length is going to be 59.5. Right? So that's what I answer, right? No, I think they mention how much must the length change. So we started at 35, right? This was our initial length. This is our new length. So I should subtract them, right? So I will do 59.5, and I'll show it here just in case you don't have audio. 59.5 minus 35. And that should get us our change, or 24.5. 24.5. So it looks like it's going to be, and they even showed 2 just to be tricky, but it's increasing, right, to match the increase in width. Really good problem, showing a change between 2 things, setting up a proportion, and then not only that, our final answer not necessarily being done, we have to find the difference, right? 17, really good problem. And this one's underlined as well, so I suspect it to also be pretty good. Let's get rid of this little extra over here, and that. I got to type on it to get rid of it. There we go. Okay, let's see what our new problem's conveying here. We have square P and square Q. So again, I'm going to be drawing shapes. So square P has a side length of x, and I don't need to say any more than that because it's a square. And then let's use a different color for our other square, Q, maybe bigger. And that's going to have a perimeter that is 176 greater than the perimeter of square P. So as soon as they say that, I pause. It's bigger than the perimeter of, maybe I should label this as going to be P, and this is going to be Q. So Q has a perimeter that's 176 greater than the perimeter of P. Well, let's get the perimeter of P first, right? So maybe it would have helped labeling all my sides. That's going to be X, X, and X. So my perimeter is, always think like a fence around something. So it's going to be my distance around my square, and it looks like it's going to be 1, 2, 3, and 4 x's. So 4x is going to be the perimeter of P. So if they say, what is the perimeter of Q when it's 176 greater? That's easy. I just say 176 greater, so plus my 4x. So this would be my perimeter of Q. And finally, let's see what they're asking for down below. The function f gives the area of square Q. So I knew they were going to get a little tricky here. Which of the following defines f? So we know this right here is the perimeter of square Q. It's a square. So each side of my square, and the reason I'm talking about sides is to get area. Area of a square is side times side, right? Side. Inside, area is going to equal side squared. So to get my sides here, they have to give us one of these shapes where it's very easily divisible. I can divide my total perimeter by 4, and I should get each side of my square. Let's see if that makes sense. So if I do 176 divided by 4, I would get 44. So let's write this down and revisit it. So I would get 44 plus x and 44 plus x. So again, if I added up 4 of these, it would get me back to 176 plus 4x. That's my perimeter. These are my sides. Now to get the area, remember, side squared. So it's going to be this times this, right? So I look up above here and I see it's going to be a little bit odd with formatting. There's multiple ways they can write this. So maybe at first glance, A doesn't look necessarily exactly what we have, but it is, right? X plus 44 squared is the same thing as x plus 44 times x plus 44, which is exactly what we have written down below. So it should be A for 18 here. We don't want to square the 176. I don't even know what they're saying in these two. A 176x, they're way off there, right? So just A for 18. And I think that's it. That's a really good, step in the right direction. These middle and end pages are going to take a little bit longer because they're more complex problems. But the whole goal is to be able to fly through all of them eventually, right, with all this practice. But yeah, we'll be back with part 3 tomorrow.